So, guys, this was a tricky one, okay? Now, before we get started, okay, what I want you guys to do, if you're ever, this is a very complicated figure, right? There's a lot of lines going on, and all we really know that's given to us is this. RSTU is congruent to UVQR. If you're ever stuck, I want you guys to like draw out, highlight, like use your pencil and outline the two figures that it's saying are congruent, okay? So in blue, let's outline RSTU. So R to S is here, so this side. S to T is here. T to U is here. And U back to R is this line. So this is one of our figures, okay? The other figure is from U to V, from V to Q, from Q to R, and then all the way back to U. So those two figures are congruent, okay? Now there's some triangles in between them, blah, 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 but we know that each of those angles are also congruent, okay? So what angle is congruent to U? The 90-degree angle right here. What angle is congruent to U in the other figure? R, very good. So we know R must also be a 90-degree angle, okay? What about, let's take S, angle S, this large angle right here. What angle must be equivalent to S? V. So all of angle V, okay? What about T? What angle must be congruent to T? Q. And those are both 90, so that one's good. We don't have to fill in anything there. And lastly, U and R, which we started with U and R being equivalent. But this R is now equivalent to this U. Samantha, what's your question?
Would S be a 90-degree angle too?
Not necessarily. All we know is that the combination of those two angles, like all of S, because remember, S is from RS to T, right? It's that large angle. That one has to be equal to V. So we know that V is 90 plus 2x plus 5y, right? It's those two angles added together. So S is just going to be equal to both of those angles as well. We do not know that VST is 90 though. Okay, we don't know that for sure. Okay, from here, guys, there's another piece of information that we can fill in, and it's related to point P. Do we know anything about these angles around point P?
That it's like 47 because the vertex or like something.
Vertical. Very good, Allison. Vertical. So this one has to be 47 degrees, right? What else do we know about P? Do we know anything about those other two angles? How could we figure out this angle? Think about this as a straight line. 180 minus what? 47. Okay? Because remember, any two angles that form a straight line should add up to 180 degrees. So this is going to be 180 minus 47, which is 133 degrees. This one is also 133 degrees. Okay? I haven't even read the question at this point. I've just filled in everything that I know. Well, I kind of read the question. I read that this figure is congruent to this figure. Okay? Now it wants to find the values of x and y and the measure of angle RST. Explain your reasoning, okay? So x and y, let's use this one first. 2x plus 5y. Can we come up with an equation for 2x plus 5y? Yes, okay? We know that 2x plus 5y plus 47 plus 90 equals what? 180. Why? What's so special about those three angles? Those three angles are inside of a triangle, right? Therefore, they have to add up to 180. So here is one of my equations, okay? But we need a second equation.
Wait, a second one for the x?
Yep.
Um, wouldn't it be the same thing except it would be 4x?
What's that?
Would it be 4x minus 3y plus 90 plus 47 equals 180?
Okay, I like that. I like that. So you need to, you're absolutely right. We need to use this, right? Somehow, some way, in one shape or form, right? But before we do that, guys, I want to stress that this angle is 47, right? This angle is 90. Can we figure out this angle?
Yeah.
What is it?
43.
43. Very good. How'd you get that?
I added 90, or I subtracted 180 minus 90, which is 90, and then 90 minus 47.
Good. So you did 180 minus 90 minus 47. Okay?
I got 43.
Yeah, perfect. Okay? Give me 1 second, guys. Trying to see something. Why is that like that? Do you guys see any other triangle that we can use? I'm getting confused. I'm looking at my notes, sorry. Confused as to how to solve this one. No, that's not right. Okay, guys, scratch this warm up. Sorry. Okay? But if you followed along to the point where we set up 2x plus 5y equals, or if you add that with 47 and 90 to get 180, you did the right thing. Sorry, guys, this one, honestly, I'm confused.
Wait, so is this going to be on the...
No, no. This will not be asked on the quiz tomorrow. If anyone can figure out how they got x equals 7 and y equals 24, let me know. But all right, so let's get started. Chapter 5, Section 3, proving triangles are congruent by SAS, okay? On this slide, just write down SAS stands for side angle side. Side angle side. Uh-oh. Okay. Okay, so included sides and angles. The included side is the side between the given angles. So for example, AB is included between angle A and angle B. So here's angle A, here's angle B. The side that is in between them would be AB, okay? That is what we call the included side. The included angle is the angle where the given sides meet. So for example, if we're looking at angle C, that's this angle right here. AC and CB would be the two line segments that include angle C. So our included angle would be C. And you can also look at it by the letters, right? So if in between AC and CB, the repeated letter was C, so our included angle would be angle C. Okay. Now, the reason we're learning about included sides and angles, guys, is because we're going to be using that for part of our congruence theorem, okay? So make sure you're familiar with what an included side and an included angle are. All right. If you're able to prove that two triangles are congruent, before, we used to have to prove that every single angle of a triangle and every single side of a triangle are congruent. What this theorem says is that side angle side congruence theorem. So if two sides and the included angle.
Is David a co-studying class?
No. He's on Zoom.
Can you go back, please, Mr. Yorko?
Yeah. You can prove that two angles are congruent if they have the same side, an angle between those two sides, and another side that are congruent. Okay? If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the angles are congruent. And I'm going to go ahead and draw a picture to make this even more clear. Let's draw a triangle with an angle here, just like that. If this is true of this triangle, then these two triangles are congruent. I'm writing with my finger because my Apple Pen just was dropped on the ground and it broke. So my apologies. Do you guys know, can you replace just the tip?
Yeah.
You can? Is it expensive?
Well, mine came with it.
An extra one?
Yeah.
Ooh.
It's in your box, like the box that came with your Apple Pencil. There's like an extra one.
There's an extra one in there?
Yeah, it comes with two.
Thank you, Ella.
You're welcome.
I gotta remember not to drop this thing. All right. So now, before we had to prove that like this angle, all three of the angles were congruent, all three of the sides were congruent. SAS, which is side angle side, says that if you have an angle, right, and there's another angle that's congruent, as long as the two sides that include that angle are congruent as well, then we can say that these two triangles are congruent. So this proves that this triangle is congruent to the other triangle, okay? Remember, this is side angle side. Oh my gosh. Side, angle, side. Okay. And guys, that's it. That's all we're learning, okay? Now we're just going to apply it using some examples, okay? All right, so example 1. State which congruent method can be used to prove the triangles are congruent. If none, state NC. Okay, so for A, we've got two triangles here. We know that this side, if I could write with my Apple Pencil, I'm just going to have to draw, guys. I'm sorry. My handwriting is going to get sloppy because I'm using my finger, but... Oh my gosh. Now it won't even let me draw. Perfect. Okay, so those two sides are congruent, right? What other side is congruent in these triangles? What do you think, Marcos?
The sides to the left and the right.
These two? Oh my gosh. These two?
Yeah.
Remember, we only know that if it's given to us, right? Did it give us that information? No. So we can't say that, okay? That's a good assumption, but we can't say that. What angle or what side is congruent? Samantha?
The arc thing.
Okay, yep. These two angles are congruent. Now, Marcos, we would need these two to be congruent in order for them to be congruent, right? Because then we would have a side, an angle, and a side, right? Now, we are not told that they're congruent. The side that we know is congruent is the shared side. We know that this side, since it's shared by both triangles, is congruent. But we know nothing about this angle or this angle, right? So therefore, we cannot say anything. So NC. Not congruent. They look super congruent, guys, but remember, stuff has to be given to us. And we don't know those two angles, and we don't know these two sides. So we can't say anything. Has to be side, angle, side, right? That angle has to be between the two sides that we know are congruent. Let's take a look at B. We've got a side here, an angle, and a side. A side, an angle, and a side. Can we prove that these are congruent?
Yeah.
Yes, by side, angle, side. SAS. But, look carefully. If this angle is 90 degrees, this one has to be 90 as well, right? Because together they make 180. We know nothing about this side, so you couldn't use that angle to prove side, angle, side. You can only use the one that I circled up above, okay? Though that three combination, the shared side, the angle, and then the side with one hash mark would prove side, angle, side. Let's do C, okay? The more we do these, the more it'll make sense. For C, we've got a side and then two angles that are not the same. Clearly this one's not correct, okay? So we would say NC for now. This angle and this angle, these are the same, right? But do we know anything about the sides here? And anything about the sides here? No, okay? So it stays as NC, not congruent, okay? Even though we know that those two angles are congruent, we don't know anything about the sides that contain them. Let's take a look at D. Side, angle, side. Does the other one have a congruent side, angle, side? Side, angle side. Therefore, we can say SAS, yes, they're congruent. A side matches up with another side, the angles match up, and then the other side matches up, we are good to go, okay? And E. Do we know anything about the sides in E? No. Okay? When you don't know anything about the sides, you cannot prove congruence. Okay? So this is NC. It tells us, yeah, sure, all of the angles are the same, but we know nothing about the length of the sides. We know nothing about the length of the sides.
Wait, so how come A isn't congruent?
The reason A is not congruent is because it shows us that, okay, we've got one side, a side, and an angle that are congruent, right? So we should be able to assume that side, angle, side, Samantha, they have to be in order, right? So here's one side, right? The angle in between that side and the other side is this one, right? But we don't know what this angle is. This is a question mark, right? It would have to tell us that what that angle is, and that it would have to be congruent to the other angle in order for us to assume side, angle, side. Has to be the interior angle, right? Or the included angle. All right, guys, more examples. Any other questions before we move on? Is that good, Teresa?
Yes.
Mr. Yurko,
Yep.
could you go to the warm-up?
In a moment.
You can go to the warm-up. I got it.
Okay. Okay, example 2. Is there enough information to prove the triangles congruent? If there is, state the postulate or theorem. ABE is congruent to CBD, okay? Let's go ahead and highlight those two triangles. I'm getting so frustrated with my Apple Pencil right now. ABE. And CBD. Okay, let's prove their sides. So we see that AB, oops. AB. What side is congruent to AB in the other triangle? CB. What's the angle that we're trying to prove that is congruent? That would be angle ABE. Okay? That's this angle right here. We want to prove that angle ABE is congruent to CBD. This angle right here. We don't know this one. This is the one that we have to prove, right? How do we know that they're congruent, though? Well, yeah, eventually. ABE, we know, is going to be this angle plus this one, right? And CBD is going to be this angle plus this one. Okay, so let's write it out. ABE, angle ABE is going to be equal to angle ABD plus angle DBE. Okay? What about angle CBD? That one's going to be equal to CBE plus angle EBD. So now let's rewrite this. We want to prove that ABD plus angle DBE is congruent to angle CBE plus angle EBD. Do I notice that there's anything in common between these two sides? Are those the same angle? Yes. Okay. So if they're the same angle, if we subtracted one from the other side, so minus angle DBE minus angle DBE, we would just get that ABD is congruent to angle CBE. And if we look at our diagram, after we write that down, is ABD congruent to CBE? If so, how do we know? Take a look at the diagram. How do we know that those two angles are congruent? ABD and CBE. Well, ABD is this angle. And CBE is this angle. How do we know that those two are congruent? Marcos?
Both have origin.
Very good. Both have one arch. So we know that they're congruent. Therefore, this is true. So our original statement that these two are congruent passes. And the last thing that we need is the sides to be congruent. And we already know that BD is congruent to BE. BD is congruent to BE. So guys, what we proved was that the line segment AB was congruent to CB, BD was congruent to BE, and then the interior angle, which was ABE, was also congruent to CBD. This is not a question you will see in your quiz, okay? This is just trying to reinforce the fact that we can understand interior angles and side angle side. Questions? 1. Okay, that was, this is actually a good one, okay? State a third congruence you would need to prove that the triangles are congruent by side angle side, okay? We're not doing example 4, this is our last example, okay? If we have ST is congruent to YZ, so let's put ST, let's put a little mark. YZ, let's put a little mark. RS is congruent to XY. Let's put 2 marks. Let's put 2 marks. Guys, which angle would need to be congruent for us to prove? If we were to only say that one angle needed to be congruent, which two angles would it need to be?
RT and SC.
One angle, guys. So we've got a side here, a side here. Remember, to prove SAS, we need one angle, one set of angles to be congruent.
S,
Angle S, and what angle does angle S have to be congruent to?
Y.
Yes.
Angle Y.
Good. Do you guys see that?
Yeah.
The angle that needs to be congruent is the one between the two sides that we're proving. Then we can say side angle side and be done. One way that will help you, okay? If you were to take a highlighter and do side, angle, side, all three of those should be congruent. Side, angle, side. All three of them are congruent, right? This is more like what you'll see on the quiz. Okay? All right. Again, we're not doing example notes. Please get started on the homework now. So if you have questions, you can ask, because this lesson will be on the quiz tomorrow.
Can you please go back to the slide example 1?
Absolutely. Does anyone need more time on example 3, this slide? Okay, example. So turn in, you guys can go ahead and